Hello, everyone. Welcome again to the third session in reputation-based weighted voting, a new primitive for DAO governance. The third session, welcome again. If you are watching this session on Twitter or on YouTube, also welcome to you. You can still join the study season, going to tokenengineering.net and register to have full access to all the materials, to all the models, simulations, to the conversations, to the recordings of the sessions. And registrations are still open. Okay, just for a brief overview, what we'll discuss today. We'll review where we are in the process, and I must say I'm super happy with seeing how much we've achieved in only now in the third week. This is really beyond expectations, and I'm super excited for the session today, because we'll have presentations from students on proposed mechanism designs. We've reached out on Discord and had conversations on what would be potential mechanisms, also how to model them, the information needed. That said, if you're planning to present today, everybody get ready, please. But no worries. It'll be a casual conversation. Ideally, you can show slides or your model and explain your design. Okay, number 3, we'll have a discussion of how to test and validate the designs. We'll discuss edge cases, the simulation tools that we can use. This will be the second big topic today. And finally, we'll check in on how to collaborate on the workflow for next week, implementing minimum 1 test or experiment. This is what we plan for today and the upcoming week. And before we dive in, let me also share that we are running a final EFCC ticket giveaway. So you might have heard that Token Engineering Academy is organizing and curating a token engineering track at EFCC in Brussels in July, on July 10th. And you can win a free ticket at EFCC. I think it's 500 euros at the moment. You can win one for free, in total 5. Please refer 3 friends to subscribe to Token Engineering Reads. We just published our latest Token Engineering Reads newsletter, and it's about the Web3 sustainability loop and the data value creation loop. It's basically an update on TE Fundamentals Module 1 with the latest insights gained from Ocean's predictor. So how to spin the token flywheel, basically. Check it out. I'll drop the subscription link for the newsletter. So just in case you know someone who has not already subscribed for the Token Engineering Academy newsletter, make them do so. Share this subscription link, share your email, so that you have the chance to win the free EFCC ticket. All right. That's it. Let's dive in. Octopus, would you like to take over?
I'm excited. I will start sharing the screen now.
Okay.
And talk about the course updates. So you know by now that the course GitHub is where we are collaborating, and there's new information on the course GitHub. If you go, there are 2 markdown files. If you go to NFT information, markdown, and NFT tasks tracking template, it gives you information about what the tasks are that can earn points, and many of you have already earned a large number of points towards the 30. And B, it gives a template where you can keep track of your own tasks, so you know how many points you have earned. And we will ask you to submit those files where you have tracked those later in the course. But it creates a format where you can keep track of it easily. And with that said, we're going to move right into talking about the designs. So in a few moments, some students who volunteered to discuss designs that they have in mind will be presenting. I wanted to present just a baseline mechanism that we've talked about in the past, partially so we have this as a fallback. We can always compare to this in terms of how well the other mechanisms perform, and also just to see what we might want to know about a potential mechanism design or process design. So the design that we have in mind here, which is, I'm not saying this is the best design, I'm saying this is a starter design, is what's called weighted plurality. Basically, each voter will have some type of weight assigned to them. And in our current example, voter number 1 has a weight of 2, and voters 2 through 4 have a weight of 1. And here there are 3 choices. And it's pretty intuitive. Each voter is going to make a choice, and we're going to add up the weights of each voter for that choice. And then the choice with the most total assigned weight based on the voter decisions will win. There aren't too many parameters here. I mean, there's a parameter for each voter, which is how much weight each voter has. And probably this would be assigned either by an algorithm that counts different attributes of the voter and turns those into weights, or some pre-agreement among the voters. The reason that parameters are important here is that parameters are what we can actually experiment with. When we're doing simulations or explorations, we can look at how different parameter choices or different parameter assignments might result in different outcomes. And that gives us a basis to consider certain situations that might be desirable or undesirable. Are y'all with me so far?
Say hello, raise your thumbs up. Okay, thank you.
If there's time, I'll tell a funny story about teaching, but I don't want to get sidetracked.
Not now, in the first 5 minutes.
Yeah. Just a basic example, if voters 1 and 2 in this chose A and voters 3 and 4 chose B, then choice A would have 3, choice B would have 2, and choice C would have 0, and we have 1 winner, which is choice A. Now, one of the things we want to think about in any mechanism that we look at is to be aware of the weaknesses at the outset. It's really easy to want to promote our ideas, which is great, but we want to be careful not to confuse research and marketing, like Dr. Mark Richardson said recently. So one of the things that we should do as we propose a mechanism or consider a mechanism is be aware of the weaknesses and failure modes at the outset, so we know that we're comfortable with those and we know we aren't surprised. For instance, one thing that can happen based on weight assignments is dictatorship. In this particular arrangement, if voter number 1 had their weight increased to 3, then it would not matter what the other voters did. All that they could do is force a tie. And this can lead to voter apathy. For instance, in this particular setup here, we have voter number 4 not voting, and voter number 1 is the only person who chose choice A, but that doesn't matter. They still, that's enough weight to win. Well, what's likely to happen in the next decision is when we redo this, that voter number 2 and voter number 3 might think, well, my vote didn't matter, so I'm not going to vote. And so we have a feedback loop where once one voter or wallet or decision maker carries enough weight, other people are likely to leave the system. And then we have a reinforcing feedback loop where the problem of centralization of decision-making power gets worse. Another possible weakness is that there could be a tie. And it's generally considered bad when we have to go outside of our mechanism for an ad hoc decision to get to the final decision. So what will we do if there's a tie? As we get to more voters, it's fairly unlikely, but we should still consider what tie-breaking procedures might be implemented or how that decision would be made if we had to break a tie. And the final weakness that this weighted plurality system has is it doesn't consider order preference. Because people are just making one single choice, information about their relative preferences can get lost. So suppose that 34.9% of the weight, not necessarily of the voters, but of the weight would view A as the best, B as the next best, and C as the worst. And then we have the other two preference rankings that could emerge. They're actually a total of 6, but I just did 3 for simplicity. What if 32% of the weight preferred B to C to A, and 33.1 preferred C to B to A? In this case, we would have about 65% of the voting weight that thought A was the worst choice, and yet A is the winner. So this does give us what the most voting weight views as the best choice, but here there's a major dichotomy. Opinion is very divided about A. And so the voting mechanisms that you learned about async in week 1 have different ways of addressing this. And ultimately, this would be considered a weakness of weighted plurality. So in just a few minutes, I'm going to open the floor for other people to present designs that they've considered, and we can discuss how they envision them working and what the strengths and weaknesses might be. But before I do that, I want to stop and ask, are there any questions about anything that I've said in terms of either the actual mechanism or what it might be important to know about a design before we start simulating and considering it in greater detail? I always get nervous. I tell my university students bored and lost, bored and confused, and I already know this look exactly the same. So are there any things was that clear? I guess I'll ask.
Probably that everybody. Sorry. Go ahead. Go ahead.
Well, for that, what you just talked about, that basically B, example of weighted plurality has in total 66% of the total weight, whether there's a solution to that or whether that is how it is then calculated and B would win?
So there are mechanisms here where there's no solution in the sense that if we replace this with a different design that would make B the winner, then there are cases where we would get things that we don't like. So there are other designs where B would win, and I think it's reasonable that B would win based on this preference arrangement. But Arrow's theorem tells us anytime we're ranking preferences, there's no like absolute best. To be honest, off the top of my head, I don't recall which designs would give B as the winner, but they certainly exist. But then those have other drawbacks.
Yeah.
Does that answer your question? Yeah. And there's a comment here. Quorum needs to be addressed. Yes. So how many people are voting with a 4-vote simple situation? Okay. Maybe one person is enough. But what if we have, like 10,000 people, or there are 10,000 voters, but only 2 vote? Is that sufficient to represent the community voice? So the idea of quorum, which I don't think we've defined before, is the minimum number of voters, or in this case, it would probably be voting weights that need to express a preference for the vote to actually count. I know that, Angela, I believe in the past you've said that you think, a good goal would be to have at least 100 distinct.
Yeah, I added this to the requirements, and Jonas just dropped it to the chat as well. At least 100 voters as part of the requirements. However, to me, this is like a target, something we should keep in mind to optimize the voting design. It would not help if we say, okay, in case we have less than 100 voters, we don't have any winner. Because then our time schedule, our goals break with announcing a fellowship winner. Does this make sense?
It makes sense to me. I mean, we have a hierarchy of requirements, and having a decision by a definite date is probably the most important of those versus other design considerations. But you're absolutely right, Jonas, that in general, the quorum is something that needs to be considered. It's just not something that is it would be a parameter of the mechanism. It's just not something we are currently considering here. Great point.
Yeah, I'll clarify in the requirements. Good call. Anything else? Okay.
Well, in that case, if we are sufficiently clear on what this basic mechanism, let's consider the other mechanisms that have been proposed. And at this point, I'm having a lot of difficulty with my mouse for some reason. At this point, I'm going to stop sharing, and we can get set up for the other people who have proposed designs to share and discuss those as well. Can we have a volunteer of the presenters to go first? I know that go ahead. Sure. So how would you like to proceed? Are you set up to?
Can I share my screen?
Yes, I will stop sharing, and I believe you should be able to.
Okay. Not too experienced with this, so let me.
No worries.
try.
Just at the lower area of your Zoom window, you should find a green button that says share screen.
Do that, but I'm not sure if it. Let's try this instead. Are you seeing anything new?
Not yet.
No, not really.
Maybe try again.
Also, maybe.
So just push this green button at
Yeah, I do, and then
Okay.
I get some layout
Mhm.
options. Use system desktop capture or use
Okay.
system window capture, and I'm trying to pick them, and then I'm pushing the button share.
Yeah.
But nothing happens.
Maybe, I don't know if you have any settings that prevent Zoom from sharing your screen.
I don't know.
You don't know. Is it a local file, or would we be able to pull it up maybe via a
maybe
URL?
if one of you could pull it from the GitHub.
Sure. Just drop the link to the chat, and I'll pull it up.
I'll do that. 1 second.
I guess I just would not be able to run simulations just in case.
The first one, it's just an illustration.
Okay,
So
good. Give me a second. Yes, here we go. This is the right one?
Yeah.
Okay,
Exactly.
good.
Okay, and of course anyone can get it by the link if you want to see the whole picture.
Perfect.
So if you could just scroll down, because we kind of have to start at the bottom.
Okay.
So this is my idea for a voting mechanism. We have the voters. Here we just see 4 voters. Of course, there'll be more. And the idea is they just pick one winner, their preferred candidate. And so what we know about a voter is that they have a preferred candidate and they have some number of NFTs. That's the list you see. And then my idea is instead of just aggregating these votes at this point, we observe that the voters belong to different groups of stakeholders, and each voter may belong to several groups based on their NFTs.
Mhm.
So there will be some experts, there will be some people who have studied the materials, there will be some active participants, and there will be the entire community. And of course, everyone belongs to the community, and then based on the NFTs, they may or may not be experts or active participants and so on. Then I would allow each group to have its own vote, in a sense. They have their own rules. So the experts are peers, they will say one person, one vote. The people who have studied the materials will say, well, if you have passed more exams, you should have a higher weight. So in our group, this is how we'll vote.
Mhm.
And the third group will say, if you have participated more, then you will have more voting power. And the last group, the big group of the entire community, will say, well, every vote counts. Again, basically one person, one vote. And so they all come out with a result, a part result, which is points for each candidate. And then my idea is we take these points, we normalize each set, and then we assign weights. So we could say each of these groups have 25% of the weight, the same weight. Or we can say the experts should have 40% of the weight and the others should have only 20 or whatever. Then we sum it up and get the result.
Got it. Or may I ask some
sure.
questions, Joan?
Sure.
You say, okay, we have different NFTs,
Mhm.
and they refer to different, let's say, community member types,
Yeah.
experts, intellectual, active participants, entire community.
Mhm.
And these community member types get a dedicated own individual voting mechanism to vote and agree on the winner within this community member type.
Yeah, they don't actually declare winner. They assign points.
Yeah.
So they will say candidate 1 gets 20 points and
Mhm,
candidate 2 gets 200 and
mhm,
so on. Then I would turn that into percentages just to be able to kind of compare the groups. So the first group says candidate 1 gets 2%, candidate 2 gets 20%, and so on up to the top. They each have 100%.
I see.
And then I aggregate those votes while I apply the weights. Maybe if you get the vote.py file, I can just show you. Might be easier. If you take the vote, there's a vote function.
Let's scroll down. Yeah, here.
Yeah. So you see, first I remove any candidates from the sample because they're not allowed to vote.
Right.
Then we ask each of the groups and normalize the results. So
I
it's
see.
percentages. And then I print some stuff and I start from 0 for each candidate. Then I take all the votes from the experts and I multiply with the experts' weight, which right now is just 1, but we could weight them differently. And then I do the same with all the others.
Okay.
And then you get a result. And the winner will be the one who has the most total points. Or again, I would normalize it back to percentages. So the winner is the one who got the most percentages.
Yeah.
In the end, just keep it.
I stopped for a moment. I have one more question that is rather how to make this happen, but I stop for a moment with my questions and just invite everyone, in case you guys have questions, let us know.
I think the concept.py is the file.
Just let me.
File,
it's the PDF.
If you want to.
Mm-hmm. Any questions here? Are you all?
I'm seeing Victor has a hand.
Victor, yeah.
Sorry, can you just explain again the normalization process? Are you just basically counting all the votes of that specific group and then just make a percentage within that group, or did I miss something?
That's exactly what I do.
Okay.
And it's just that of course the community group would have maybe 200 voters in it, and the experts group would have, I don't know, 5. And it's just to if I don't turn it into percentages, then there will only be 5 points in the experts group vote, and there will be 200 in the community votes. So I turn them into percentages because then they are comparable, and then I apply the weights that we have agreed on. Because then we get to control how much power should the experts have compared to the community.
There's a question from the chat, which is I see here in your graph that there are multiple arrows. So if someone is both an expert and an intellectual, does their vote count in each category?
Yeah, that's my idea.
Okay.
That would have been my question as well, Joanne. So community members are not required to vote multiple times, right? It's just that we count them in multiple groups.
Yeah, they qualify for every group, then they get to influence the decision in every group.
I see. Yeah, good.
But then so I think you mentioned that every group can have their own voting mechanism. Is that correct?
Yeah. That's
then
this is my implementation right now.
So if, for example, say an expert is also a part of the community, expert group has one voting mechanism, and then they, in order to also contribute to the total of the community vote, they would have to vote there separately, right?
No,
okay, can it be transferred somehow, their choice?
Each person just votes once, and then we have their vote. And then we look at the group of experts, and we pretend that they make a vote of their own. I mean, we have the vote, but we just look at the votes of all the experts. And then we look at the group of participants, and we look at the group of the entire community. I'm not sure if I'm...
And then the expert would not be part of the community group because their vote is recorded in a shape that is like specific to the experts, or can it be also in the community?
Voting, no, sorry. Yeah, I can see. I think I understand now your question. In any case, a voter just votes once, and he just votes for one person, and that's the same across the board.
Okay, yeah.
And then the way results are calculated within each group may be different, but the basic input is the same.
Yeah, okay, yeah, gotcha.
Yeah, so that's an important detail, of course.
So I'm clear that I understand, and also for feasibility of implementation. It sounds like what you're proposing is that we have different categories, and then there's essentially like a sub vote or sub election for each category, and then we combine the results of the different sub elections from the different categories. Is that accurate? I want to be sure I understand.
Yeah, just except that we just have, I mean, again, there's just one voting interface. Everyone would vote just once. But then behind the scenes, we pretend that we have these categories, and from that point on, we kind of pretend that we had 4 elections. But
And in terms of implementation, this would mean, okay, we start here with wallets, and wallets are assigned, and the NFTs identify the member category, right?
yeah,
Expert,
so it just, the NFTs are the certificates that
Right.
allow you to be a member of any number of groups. Yeah.
Right. So what's maybe missing, but this is just for my clarification. I think the image is great. The diagram is great. That at the very lower end, we have wallets holding multiple NFTs, but these wallets vote only once. And thus we get an input value of the voting that is then distributed across these categories of members. Then we apply a certain voting mechanism to land at the result here on candidate 1, 2, 3, 4, and assign a certain percentage to finally land at the outcome, the yellow heart. Correct?
Yeah.
Okay.
And I guess you could just, if you scroll down, you can just think of the one smiley face with one vote and one list of NFTs. That is kind of your wallet.
Yeah. Okay. Yeah.
Does that make sense?
Makes total sense.
Perfect.
How would you envision the process to get to these different voting mechanisms per category, per member category?
I'm not sure I understand the question. I mean, I have a suggestion, of course, which is basically what I wrote here.
So in the expert category, we say 1 person, 1 vote. In the intellectuals category, we say more exams, more voting power. This is okay.
Yeah. And if you take the concept.text.
Yes. Okay. Yeah.
And then scroll down a bit. I have detailed my suggestion for each group. Yeah, you just scroll past it. If you go up a bit, here you have it.
Okay.
So
okay.
That's my suggestion, but of course it's all up for discussion.
Yeah.
So the weight, but that's an idea.
Awesome. We have more questions. Victor.
So just very quickly, basically, if I understand correctly, I would kind of try to ask myself, like, how many of these experts group actually also have, done the other exams that are more probably targeted towards, the fundamentalists or the people that are maybe more on the starting side, because I guess this framework is fantastic, but probably if you see in that exercise that there's a clear segregation already originally between somebody who gave a speech in the ECC or somebody who's leading a working group, and they have just not done the token fundamentals because maybe they think they don't need it or for other reasons. And so then maybe it's maybe you already see it, it's very clear, and then you just try to create like groups where they're already very segregated. And I don't know if I'm maybe a bit confusing, but does it make sense? So if I have this, I'm sorry, I just made a quick screenshot. So I would say the experts on the very left, they are for sure contributing to the community, but maybe a lot of people that are intellectuals that have done all the exams. I think they have the opinion, more exams, more voting power. Maybe they're actually quite isolated because they haven't given any I don't know, they haven't been a speaker, or they haven't done any of the other parts that gives you NFTs. Also because maybe they didn't even have a choice, because they just started in 2023 and they can't go back in time. So bottom line is, down the line in the future, in 10 years, this will be fantastic. But maybe right now, if I just look at all the NFTs, and maybe you actually have very clearly defined groups, and then you will see that, going through the exercise, that it's just as good as allocating just a number. Like, let's say the experts have, I don't know, weight X and intellectuals weight Y. But that's just kind of what I want to say. I hope it makes sense.
I think that's actually what I'm doing. That's kind of the idea, that they are somewhat separate groups, and the design kind of just, acknowledges that and makes it explicit, and makes it explicit that we kind of have intuitions about how much weight do we want the experts to have, how much weight do we want the active participants who may not know that much to have. I mean, in a way, that is what we are discussing. So this design suggests that we just make that very, very explicit.
Yeah. If I may interrupt, and I agree, it makes some hidden parts in a voting design very explicit, and this is what makes this proposal really great. I wonder if this was a great starting point, Joanne. Can we move the conversation about this design and then next steps in verifying to the second part of the session today? Because we have two more presenters, and we'd like to give all of them the chance to share their design, if that's okay. So I stop the presentation here. You can all find the link to Joanne's GitHub in the chat. And now, who should go next? Who wants to present?
We have Bryn going next, and then Felix will follow them. So.
Okay, good.
Hey. Can you hear me okay, guys?
We can hear you. You should be able to share your screen.
Can't turn the cam on because I'm with my baby, but let me share the screen with you. Okay, can we see that?
We can see it, yeah.
You can see my slides. And if I go like that, and then on the other PC, I can actually see my speaker's notes, because for some reason that doesn't work. Okay, cool. I'm going to come clean first and say that this is one of my first forays into code and developing. So I'm not that experienced on that side of things, but I have helped to launch a lot of products and bring them to market in the past. So maybe my approach is a little bit coming from a product developer, product manager kind of perspective. So if we go to the next slide, yes, the design principles were based on the requirements that we had, establishing a clear timeline, ensuring that all the participants agree on the voting mechanism, and then selecting a single candidate as the winner. So yeah, it's focused on fairness, merit-based voting, and security. I hope you can all see the little sequence diagram that I put there on the right-hand side. Let me just move this Zoom pop-up thing. So you can sort of see the process here, whereby the voter logs into the platform, initiates the voting process, then it verifies that they have the TE NFT via a smart contract on Optimism, checks the record on the blockchain. When the blockchain verifies that, then they are verified to vote. If they are verified to vote, they can confirm and cast their vote on chain. This bit I haven't built out, obviously, yet, but I would like some help from any smart contractors to help me figure that bit out. And then the vote will be recorded and the confirmation will be displayed. and it will also give them the results as well. So those will be tallied, calculated, and returned from the blockchain. We set a timeline of 1 week for this, from June the 13th, I believe it was. And if you take a look into the code that I put on Google Drive, I haven't yet put it on a GitHub. Apologies for that. I will do that over the next couple of days. Here we have a query to the Octopus subgraph, which is where the TE NFTs are issued from. And there's this. Thanks, Angela, for the code for this as well. There's this raft ID, and that lets us know whether the NFT is a special contribution or a TE module NFT. So just experimenting with weights and rankings on them as well. So I was able to get it to assign a weight of 1 for let's say the proof of knowledge ones, and a 2 for the proof of special contributions. Now that can be edited at any point, and I think the next bit of the conversation is how do we rank these different contributions. If we just go forward, okay. I'm actually going to skip to this slide first, because this is more of a breakdown of what the NFTs are. So the image on the right hand side is the results that I got from querying that database of NFTs, and I hope this is correct as well. Please let me know if it's not, but there seems to be a lot more of the TE fundamentals NFTs that are out there, which you kind of expect. Oh, here's my little token engineer. And then there's also some of these special contributors down at the bottom. You can tell the difference because they're weighted 2 for those special contributions. That was defined by the different raft ID on the NFT. And then there was 347 total unique NFT holders as well. Okay. One of the considerations, give me a second. One of the considerations was that people should have more of a reputation or more of a weight in voting based on the number of NFTs that they've got. I was struggling to find a way to get the amount of NFTs. So if someone holds like some special contributions, some TE fundamentals, proof of knowledge ones, sorry, I was struggling to get it to add up their scores into greater reputations. If anyone can help me with that, that would be amazing. But I did manage to get it to initiate a vote with people with like, as if they have 1 NFT, for example. So on the right hand side, you can see a simulation of that there, where we've got a clear winner with candidate B for this 20 voter simulation. Okay. In terms of weaknesses and considerations then, so I think there's going to be some complexity of people participating in the system, about understanding the weighting behind the voting system, and also the complexity of setting weights for the different NFTs. Like, do we want to reward some of the more difficult proof of knowledge ones a bit more than some of the more easier fundamentals ones, for example? Certainly the DeFi liquidity one for me is a lot more difficult than some of these tracks. We want to add different weights for some of these speaking contributions as well. I think Victor was talking about that earlier. I need a way to check wallet addresses for NFT ownership. Again, I'm not that skilled as a developer, so I need some help with that. I think there's as Victor, I believe, also mentioned, there's a risk of overemphasis on the past contributions by NFTs. So, over time, this might get better, but you want to be rewarding your active participants at present and letting them also contribute to voting as well. So maybe we should figure out a way to incentivize people who are active right now to participate. Yeah, as mentioned before, I need a CTO really to help me finish this. Cool. Okay, so that's it for the presentation. I guess we'll open it up to questions.
Super, Bryn. Thanks, number one, for presenting your mechanism, and thanks, number two, for presenting, let's say, the team skills you need. I mean, being aware of the gaps is also something very important. Thank you so much. I think this was quite straightforward, and I would want to let the next speaker present right now, since we are otherwise running out of time. I hope Bryn's presentation was super clear. Otherwise, just reach out with questions on Discord. I'm sure Bryn will be happy to answer. Okay, who wants to present?
All right, so I think Felix and I will be presenting.
Good.
Yes, exactly. And Jade is taking the lead in the presentation, so it would be best if you share the screen, right?
Yes, except for the fact that I'm trying to share my screen, but then I have so many windows open and they're not being descriptive.
Yeah, no problem. I'm trying to share my screen.
Okay, great.
So okay, you should see my screen now.
Loading. Right? Yes.
Okay, perfect. We'll also try to turn on my camera real quick. Okay, perfect. So then I will just go to the. Is there some presentation mode here? I haven't used it.
I think it's fine.
Okay. So then I would just go to the first slide and hand over to Jade.
All right. Okay. So can you see the first slide? It's coming up a little odd for me.
Looks great on my screen. Should be fine.
Okay. Gotcha. Okay. So our voting mechanism is called quadratic credibility voting. And just to give a brief background on us, Felix is from Germany. He has a bachelor's degree in science in computer science, software engineer for SEMA software. He's been interested in blockchain for 4 years and token engineering for 1 year. I'm based out of Colorado in the US, bachelor's degree in physics, and I am the new programs lead for TEC. My crypto age is 1 year old. So without further ado, we can get into the voting mechanism, and we'll be going into the assumptions, and I'll hand it off to Felix to go over those.
Okay, thanks a lot for the introduction, Jade. So some basic assumptions we made at the beginning is that the grant that is collected, and maybe I just go one step back before, and the mechanism is specifically designed to distribute grants or funding. So the first assumption we made is that the grant or funding collected is an estimation of the social surplus provided by one of the candidates or all of the candidates. So that's basically how the contribution or what the fund will be distributed to is valued by the community. So therefore, we have some value bounds. We can say the maximum value assignable to a contribution by one of the candidates is exactly the whole amount of the grant. And yeah, the minimum value is nothing, just 0. So nobody is able to make a negative contribution, I think. Okay, so, and what we are trying to do, so that's like the basic premise of the mechanism. We are using the weights to distribute some virtual currency, virtual token that reflect the grant amount. And this should be used to make a very precise discovery about how much value is provided by the different candidates. So I will leave something for Jade later. I don't want to explain like everything right now. But yeah, that's basically the idea. So we have the grant amount, we have the weights, we distribute this amount between the voters that they can assign a very precise value to the candidates and their contribution. So the voters act as an estimator in the mechanism, and yeah, we are using their choice to assign a conceptual value to the candidate. And when we look at the mechanism through this lens of valuations and how different voters are valuing the contributions, we will also be able to make certain guarantees about the mechanism, but we are not there yet. So all of this, we had also done a lot of mathematical definitions, took a lot of time. So there wasn't enough time this week to go into a deep analysis of incentive compatibility, but something like this will definitely follow in the future. So that was my part of the presentation, and I hand it back to Jade.
Okay, let's keep the time in mind. We have
Okay.
one more presentation and 10 minutes left. Okay, let's go.
Okay, we can run through this. So this slide is just defining some of the variables and functions for mathematical representations. We have our voter set, we have our candidates, the reputation sources like NFTs, the weights of the voter, the tokens that would be allocated to vote per voter, and then the final calculation of the quadratic voting of all of those voters given their particular reputation weight. And if we go to the next slide, then this is how we are essentially taking into account for reputation. We are going to be applying weights through proof of knowledge, through fundamentals, NFT-based reputation modules, proof of participation, registration, if you were a speaker at the study season or at ECC of last year, or if you're a member of the fellowship community. And then in the next slide, based off of the reputation, we are going to distribute the tokens to the voters based off of their weights. Yes, okay. So for example, we have 15 voters in the leftmost column, and then we apply the weights based off of their reputation. We then take a percentage of their weight based off of the total weight of the collective, so it's all relative. And then we apply it to the grant amount, and the voter is then given the amount of voting tokens based off of this calculation. And then after they're distributed, the voting tokens, then they go ahead and vote for their candidates. In the next slide, we see an example of 5 voters who have been given various degrees of tokens, and they vote for their particular candidates 5, 6, 7, and 8. And in the next slide, the last one is how we calculate the actual voting. So we apply the quadratic funding mechanism to the votes based off of reputation weights. And so in this example, then candidate 6 is the winner of this particular mechanism. And so, yeah, that is it. And thank you so much.
Okay, let's have two questions from the audience to clarify.
Sorry, Angela, can I just mention two more things I forgot in my slide? So the mechanism is very general in the sense of that you can apply to different scenarios, right? So you can make certain configurations like all voters have to vote all their token on one candidate, or they can distribute it. Or let's say, for example, we have one winner, we have multiple winners, or just the best 3 candidates will receive some amount of the grant. So there's like a lot. The mechanism is on purpose very general, that it can be applied in different circumstances. Okay.
Cool. Thanks. Makes a lot of sense. If you guys don't have any questions, so switch on your mics in case that are for this, but these questions are general, so I can ask them later. So remember, perfect. It's totally cool to discuss further on Discord. Just for my general understanding, so envisioning a diagram similar to what Joanne showed. So you take a first step and say, we calculate based on reputation, we distribute tokens for the voting. And then these voting tokens are used by the voters to assign votes to candidates, right? So we would basically have 2 rounds of activities. I see.
Yes, exactly.
So yeah.
So Saremba, feel free to switch on your mic simply.
All right. So these questions, as I mentioned, I think they're relevant to all mechanism, not just this one. But I really like how in this mechanism there was this idea about the value discovery. And so one of my sort of questions or thought processes is that I think it is important for decision making to potentially have some separation between the value discovery or information gathering versus decision making. And the reason why is that in the value discovery or the information gathering step, I think this is the step where maybe you want to be able to have output from various people, from people with like various knowledge, experiences, and potentially like values and incentives. But when you go to the decision-making process, so the actual voting, maybe you don't want to necessarily include absolutely everything, so that you don't end up with a too complicated voting mechanism, but being informed by the value, that's when sort of people can maybe make a better decision. So and the other reasons to that is that I'm thinking that however we sort of separate the different groups, those groups are probably going to evolve in time. So if we think about a mechanism that is not one-off, but is a mechanism that might work in like later situations, then we wouldn't want to end up in a situation where maybe the composition of the groups changes, so their values, their, I don't know, opinions and like incentives change. And to further that, we might have a situation where maybe like, I don't know, the experts, maybe they have incentives that are connected to both I'm short of the word, not wellness, but like the
healthiness, or
well, the health of the community. But also they might have incentives strongly connected to their professional development and sort of their, I don't know, earning potential. So it might be that they would want to strongly skew the direction of the decisions that make it sort of make their job of career oriented incentives sort of I'm short of words, but I think maybe you know what I mean. There is the risk, and it's not necessarily that people might have like bad intentions or anything. It's just that naturally that might be their biases. or
Right.
you might have maybe at some point a particularly good marketing of the fundamentals to specific group. I don't know, maybe like suddenly one university, or suddenly a company wants to have all of their employees take the courses. So there is a potential of maybe even sudden and short-term skews.
Mhm.
So with all of that, it's important to be able to maybe properly understand the value for all of those people, to make sure that the incentives are actually aligned with the healthiness of the whole system.
Yeah, absolutely. Thanks for highlighting this. I think this applies to, as you said, it's a general observation, applies to all the mechanisms we have seen so far. And yeah, I'm really impressed by what we've seen about the many implementations of this reputation. How can we reflect reputation? And then how can we make this explicit in the voting outcome? Super cool. I'd like to have the final person, not sure who it is at the moment.
I'm going to betray my ability to handle names. It's either Jonas or Jonas. And then after this, let me go ahead and preview, if I could, what's coming up so people are prepared. We will be moving on to a brief discussion of validation and testing. We have two students.
Wait, Andrew, should Jonas present first, or would you like to?
If Jonas is,
I just prepared a little bit. But yeah, you let go.
If you're ready, you can jump on.
Yeah, I'm ready.
Filling.
Okay, because we already saw Jonas' slide. That's why I was confused. Okay, good.
Okay, cool. Yeah, I'll, in the interest of brevity, short of time, I'll make it short. Anyway, yeah, I think my idea builds nicely on top of others like Felix and Bryn, I think it was. Basically, I'm just imagining a voting slider like this that people can rank their candidates on, and then it in the background it would use a very similar algorithm to what they presented before. And it's just about, you know, whether I like that candidate or not, or, you know, how much I vote for them. So a very simple and engaging user interface. I wrote a little bit more here about the scoring, how it works, but yeah, I think the mechanism is very similar to what we've seen before and doesn't need to go further into it. And then, yeah, I wanted to, oh, sorry, is there?
No, maybe it's worth going over the steps. Otherwise, it's hard to follow. So 300 points to distribute. Okay.
Yeah, so each voter, it has points according to how many NFTs they have, how many qualifications. So yeah, various mechanisms to distribute those points. We've already seen a few before. So like if you have 30 NFTs or so, you might have 300 points or whatever. Or they could, depending on how many hours each NFT took to get, or some things like this. So each voter has a different number of points. Then the voter would drag the candidates here on the slider. So they distribute in some fashion. And then, so I have one example where, for example, one candidate is put here at around 20%, then two at somewhere in the middle point, and one is at 70%. And then it would also distribute the points. So basically also normalize like how Dren did it, and give 31 points to the 20%, the candidate, then 79 to each of the ones in the middle, and then 110 points to the last one. And then basically all the candidates would aggregate those points from the different voters, and then we will have a winner. And it should be reasonably clear who that is. Like having a tie is very, very unlikely. But yeah.
Okay.
Yeah, I think that's the main thing for this.
You just showed a GitHub?
Yeah. The other thing that I did was I actually spent most of my time working in Joan's repository. So this one here's just my fork and writing a few tests. And yeah, so I under the hood, how this slider also would work is in some way very similar to ranked choice voting, and I like that. That's one of the pre-made algorithms that I discovered. And I wrote some tests for that and discovered that sometimes it is quite difficult to get it right. And there are some things like if there are too few voters and then they vote for a different first candidate each, then the algorithm doesn't work. There was also one other requirement that, like, usually the ranking should not change, that the outcome should not change if you take away one of the candidates. So the relative ordering. So I tried to test that one as well, whether the different algorithms that we can use adhere to that principle. But yeah, also the first one that I tried, immediately it said, oh no, actually this one here changes the order if you just remove a candidate. So just note on that we have to be a little bit careful about these kind of things, and we have to test thoroughly our algorithm, whatever we are going to take. And I think that's it.
Cool. Thanks, Jonas, for presenting. I hope everyone was able to follow. I think it's also a very straightforward way of assigning votes. And again, I think it's really worth continuing the discussion on these voting algorithms, because we are just at the starting point of the design, and now the whole iteration on verifications just start. And Andrew has some inputs for us before we move on in the breakout rooms.
Yes, so what we want to do now is coordinate in breakout rooms what our validation testing efforts will be, so that we can continue to move forward with making sure that we're on track for making sure that we have thoroughly surveyed what can happen. Because everyone likes, I mean, it's fun, it's really awesome to build a car that can move fast. We also have to look at how much damage will there be if the car crashes. So we want to focus on a couple of things. One is, how much are we exploring versus are we looking at a more experimental focused mindset? And what are the tools we have to know what we know? And to know that we know what we know. Because if, for instance, we build a simulation engine, but there are flaws in the simulation engine, then we may not be confident in the results. So just like with the designs, I've invited a few students to present tools and test cases that they've looked at. Then after that, we will break out into breakout rooms and focus on what are the next steps of what we can do to come back next week and be prepared to talk about testing and validation, and also have begun some testing and validation efforts. So Eren, would you be willing to present your spreadsheet tool first, and then Victor will come back to you for the test case that you wanted to share with us.
Right, tells me you can't start screen sharing while collaborating on a whiteboard. Right.
Should be fixed now.
Should be fixed, right. Yeah. Look, what I have in here, are you able to see it?
Mm-hmm.
Okay, so I tried to build an Excel model that would, help us to test out a few things. And the important bits in here, I think, fundamentals that we have assets, weights in here. Currently, everything you see here are randomized. So it's built with a one form or the other, a rand between formula, right? So we can assign asset weights in here, and it would just give us a weighted score, and measure the weight in percentage, and also rank it, right? So we can implement 3 different types if we want to. And I've taken upon myself to test out 4 different models in here. One of them is just a basic plurality. Second is coalition choice. Third is IRV, instant runoff voting method, and the last is quadratic voting. And to keep it simple, what I'm going to do next is assign these weights in 3 different types into the models to see what type of differences that we'll be seeing. Deltas will be there, and I need to work on a suitable balance in the available credits on the quadratic voting, and how to base what type of weights I should be using, either the percentage rank or the direct weighted score. So currently, when I share this, you're going to see this table is full of identifiers on the permutation table, so you can't directly just multiply them by their weights. And to find an helper table and intermediate layer in order to execute this, it will probably take me another few hours to get it done. But once it's done, I'll just upload it, and you guys, anybody wants to play around with it, just take it to the next step. I think it's just works as a basis. So that's that.
Awesome.
I'll share the group.
It's amazing to have more tools, and it would be awesome experience for us to implement the processes that are being proposed into these tools so we can test them as well. And Victor, would you be willing to discuss the edge case that you've identified that you'd like to share with us?
Sure. I'll try to keep it very short. Just give me 1 second. Can you see my slide?
Yes.
I just,
yeah, no.
Yeah. So basically, what I tried to do is just to ask myself, how would we be able to defend ourselves against a potential attack? That would be the edge case. That should be actually the first slide here. So basically, what I did is I reduced the complexity to a voting design that is very, very simple, but you could just take the same idea and probably extrapolate it to all the other systems as well. So you have basically here the assumptions, or the design that's for candidates, and the candidate obviously with the highest number of weighted votes wins. We said that the voters have weighted votes, and they have to be according to the experience. And I did some calculations, which I'm not going to show here, but I'm going to talk about them because they're very, very simple, kept simple on purpose. So only voters with at least 1 NFT are eligible for a vote. And each voter can only vote for 1 candidate. That is in that simplified model. And the last thing is every PE Academy Fundamentals NFT has the weight of 1. And then my rationale, just very simple, why I gave the weight of 7 to all the other NFTs that would be for the HCC presenters, speakers, etc., would be that if I, completely new to token engineering, would just spend a lot of time and in a matter of a week go through all the fundamentals courses, I would have a weight of 6, because there are 6 of them, maybe including the NFT-based reputation and web. So basically my idea was, if you're a speaker at a conference, maybe it would be, the rationale would be that you're at least 1 ahead. And then the other requirement for me was that all the votes, like all the weights together of all the people that are not speakers, that are basically PE fundamentals people, they should still ideally be higher than all the weighted votes together of the more experienced group, because that kind of equilibrates it in a more larger context. But then again, that's just an opinion. I just give you the framework to kind of follow up in the next 3 slides. Okay, so basically the objective is to defend against the manipulation, and then also give more experienced voters more weight, but not disproportionately somehow disadvantage the less experienced voters. And so conceptually, I just thought, okay, what is the most difficult voting result to manipulate? It would be if, in a very unlikely case that everybody votes for one candidate, you would have, according to my system, with 1 and 7, like 1,836 weighted votes on that you would have to basically beat. You would have to make that amount of wallets, or +1, so 37, with at least one NFT base or any kind of NFT, so that you can, and then you can somehow extrapolate and think about how much time this would actually take, like in hours, maybe in days, to actually do that, to give you an idea of how difficult it would be. So what is then the other scenario? The second scenario would be the easiest, I guess, in my thinking, the easiest vote to manipulate. Also very unlikely that everybody has exactly the same amount of weighted votes, like 25%. But then ideally you just need one NFT, and that wouldn't actually literally probably qualify as a manipulation, because it could be just coincidence. So I just wanted to kind of, I think this is the key slide, just mention that I guess the message is, if you assume that like there's at least a 10% deviation of the total equilibrium, that is very unlikely, but that gives you an ability to just somehow say, okay, how many votes, like if you count in terms of in that system, one NFT would be one vote, then you would have to create 46 wallets and go through 46 courses, like to get one NFT in each wallet. And that's pretty much, like, in my opinion, kind of in that system, the easiest, or the minimum that you would do to manipulate it. Any deviation from this, which is very likely, because it's very unlikely that you have such an equilibrated voting outcome, that would make it even harder for any attacker. So then you can think about how many hours this would take, etc., and how necessary, or how necessary it is to make the system more complex, or therefore more robust against an attack. Okay, I'm going to stop here. If there are any questions, happy to answer them.
That's a great scenario, and I love how you framed it in terms of cost of attack, because that's one of the things is that, it's extremely unlikely. All of the candidates that we have are very reputable people. But if we were to have a dishonest candidate in a future election, that's a lot of effort for $10,000. And it probably would cost them more in terms of effort than they would actually gain, assuming they're a rational actor. And that's one of the things to look at.
One could possibly argue that if they are going through the exercise, they will be so good because they have so many NFTs earned that they might do service.
But generally, I think this is a really good exercise to land at the scenarios to conceptually explore the costs of attack, the vulnerabilities. So thanks for sharing.
So basically, I know this is extremely simplified, and so you already see all the other people have put a lot of very rich information into this. So but it's still kind of applicable to any case. But thanks a lot, and thanks to everyone.
Well, it's great to have those very concrete scenarios as well, because we want this to be maximally understandable. So having something that's very concrete to look at helps us understand what we're talking about. So with the time we have left, we want to coordinate our efforts. I've seen, for instance, that people, some people have said, I might need help with coding this part, or I might need help with I might add this to the spreadsheet. And so we want to different rooms, and these rooms are.
Wait, I'll pull it up.
Put them in the chat. Angela, do you have the?
Yeah, I can read it out. So we have created 4 rooms. Room number 1 is called spreadsheet template. Room number 2, simulation tools. 3, data exploration, and 4, test cases and requirements documentation. So maybe before we now jump into the breakout rooms, Andrew, let's go over what's the task now.
Yes, so we want to identify the next steps that we see in terms of making it possible for us to discuss these mechanisms by using the tools that we have built in our building. So for instance, there have been multiple Python representations. It may make sense to see if it's possible to merge these into some kind of compatible repo. For the spreadsheets, we would actually need to have spreadsheet calculations that work with the proposed mechanisms. We would need to add those in so that we could compare them on an apples to apples basis. The issue has been raised that we want to understand the landscape of what the weights are as they currently exist, which would be actually a data science question. Maybe we're visualizing how things look now and how they might change between now and the vote date. And finally, we want to make sure that there's room for very specific test cases, clear on what the requirements are. So when the breakout rooms open, we're going to ask you to go to the room that you would like to work on for this week. Would you like to work on improving spreadsheets, work on the Python simulations, work on exploring the data as it exists, or work on writing test cases and requirements documentation? What we want to leave with here are very clear goals of what we hope to accomplish in each of these directions when we next meet. And we want you to decide the next steps, and then the points earning tasks will be for you to publicly document what you are going to do this week and to then actually execute it before the next meeting. Our goal for the next meeting is that we're able to all play with the different mechanisms and see how they behave in different scenarios. So what we really want to focus on this week is the tooling and making sure that we have consistent tools that are accessible to as many people as possible. Would you say hooray in the chat if what I just said makes sense?
Okay. Andrew, just for clarification, next week is not to decide on a certain voting mechanism. It's about using these 4 tools to continue the iterations on the design. And basically, it's up to you which design you find most interesting to team up. I think we have seen 4 great first approaches that we can further refine now using these tools. That's the idea.
Yes. Next week, we want to continue our discussion of the different designs, and we want to have tools in place where we can have evidence for different claims. We're not making the final decision next week. Mm-hmm. We just want to be sure that we can explore together.
Mm-hmm. Okay, all good. So I'll now open the breakout rooms, and you can just choose which one you find most interesting. I'll open the room, and you can just select yourself which room you'd like to join, and then we'll meet again in 10 minutes. Come back to the main room then, but I'll let you know. Okay, please, everyone, choose the room. Either spreadsheet template, simulation tools, data exploration, or test cases.
If you're new to this, you may need to be told there's going to be a small rectangle that pops up for you that says join a room. And then when you click on that, you'll see the options and you have the ability to click join. So
right at the lower section, I can't share my screen because Zoom doesn't display its own menu items, but at the lower area of your window, you can find the 3 dots and then choose breakout rooms.
Yeah. Great. And the one thing I'd like to add is some people may be saying, well, I'm not technical, I'm not a coder. The technical / coder people really need you. because they need to know what it would be like for a user who's trying to get information from this. So especially for some of these things, they may be able to tell you how you can present the information in a way that's comprehensible to them. So far we've had 7 people join rooms, and if you would just continue joining the rooms that you're interested in, the outflow of this will be that we continue this discussion async in Discord, but let's take advantage of this time that we have. So Angela and I as instructors will be going around to the rooms and helping to coordinate as needed. So those of you watching on the stream, you will not see much. Join us next week and you can be more engaged in this part.
Yeah, or stay online. We just pause here on the main room for 10 minutes and then come back again.
Quick question. Anyone here?
I'm here.
Hi.
Eren.
Now, the spreadsheet tool that I was trying to build, it's actually a simulator. So sort of stuck between, like, I'm happy to, I mean, I'm eventually going to, finish this up because it's a job started. But I don't know whether this qualifies as a tool for simulation, or it qualifies as it is a spreadsheet, but it is a simulator. So,
yes.
What do you think?
So in a sense, your system with the spreadsheet calculator, it doesn't evolve over time. But since we have a voting, we most likely will have a scenario where this is not time dependent, and that's why it's suitable to be simulated in a spreadsheet calculation. And that's why it's perfectly fine.
Right. So it counts as a spreadsheet group, right? It should be included there.
Right.
Cool.
And I guess with what you've built now, it's just a great fundament for all the ideas we have seen today and for all the teams we've seen today.
Yeah, that's
to make use of it. Exactly.
Yeah. It also has, a certain parameters that, counts in quorum and seeing if everything is fitting, and just it's based on the requirement sheet. So, all right, then
awesome.
I'll just drop it there.
Yeah. So make sure everybody knows about it and support them in making use of it.
Sure, absolutely. All right, then I'll drop there. Thanks.
Yeah. back. And now I'll close all rooms. Okay, let's give it a moment to give everybody the chance to come back.
Well, Loretta, can I ask a few questions?
And we'll continue in 10 seconds. I'm so sorry,
Right,
really.
no worries.
It's always too short, the sessions. But feel free to reach out on Discord and happy to jump on a sync call. I just have to check if, yeah, we have everybody back in the call. So I hope you all had the chance to start a conversation. I know that this time is always too short to land at the result, but I think, Andrew, the idea was to get a conversation going, right? I'll share the slides again so that we maybe, Andrew, should we go over what's now the homework again?
Yes. So it's possible that the rooms may not have reached complete consensus on what the objectives are for the week, given the how big a question it is. So I think we move the discussion to Discord. It'd be great if we could create threads for sort of each thread that we're following in the work streams. And our goal first will be to come up with what we want to do. And then each individual can self-assign a task for what they will do. So the self-assignment we'd like to occur by basically in about 48 hours. Just come up with something you can do this week that will advance our understanding of the mechanisms, and hopefully it's something that can simultaneously advance our understanding of all of the mechanisms, because our goal here is to have, fair comparisons of the different situations and to let people run simulations fairly easily. If Angelo or I approves the task, we'll give you a thumbs up, which means go ahead. If it seems like way too much or way too little, we'll converse with you about that. And then finally, we don't have a point value on this, which is my oversight. 7. Does that sound good? For 7 NFT points, you complete the task that you self-assigned, and then we will be in a place next week where we have more tooling in place and can actually do validation and testing is the idea. I realized the final discussion was a bit more compressed than we might have liked. I think we'll work out the details in Discord. But does the big idea make sense for what we're hoping to do? Okay, I got one nod, which is like so much confirmation. It's awesome. And people are smiling, so no one feels too, if you feel okay about this. I got a thumbs up, that's awesome. So it does look like we're pretty clear on what we're going to do now. And again, the goal is progress. So whatever we can figure out in the next week will be further along our understanding, and we can certainly provide clarity and structure as needed.
And one more note, Andrew, just to confirm this, I think that yes, what you do over the next week can and should be valuable for basically all ideas, all voting designs discussed today. But of course, you can choose one of the presenting teams and wrangle and discuss how you could contribute in terms of, can I work on a spreadsheet verification of your design, or can I work on the data exploration behind this design, or I think I have detected an edge case. Let's discuss it. Of course, feel free to connect it with one or several of the ideas presented. It's just we'd like to switch modes a little bit and get away from the design into verification and certain practices and tools. I hope
And what
this
we're
helps.
doing here, yeah, what we're doing here is making visible the part that's usually invisible. Usually the DAO votes, and then other people have to go away and implement it. And we're implementing it together, and we're all seeing how messy and how exciting it is. So that's really fun, I think. So I vote that we move all further discussion to Discord, and any questions that aren't clear about this, be sure that we address there.
Yeah. And there's one more task. If you don't feel comfortable with picking up a task that we discussed so far, I need one more volunteer to work with me on an update for the optimism community, just to share where we are at the moment, what we've achieved so far, and what we are aiming to build and provide in the upcoming weeks. Is there anybody? I can do that, Bryn. Okay, I'll sync with you, and we'll take next steps async. Good. Are you guys ready to continue the collaboration, working on the voting mechanisms on Discord?
And everybody's
Yes. Yeah. Yeah, super excited thank you so much, everybody, for preparing the presentations. I must say I'm already, what will this mean? Because ultimately we want to roll out something amazing for the fellowship voting. And yeah, thanks for today. See you on Discord. Bye, everyone.
Bye.
Bye-bye.
Bye.
Ciao, ciao. Ciao, ciao.
The recording has stopped.